Hi class, so this is my video that is going to go over some of the basics with Anova once again and discuss the homework. So the first thing that I was going to have us do is I have this great data generator, and so what I'm doing is I'm going ahead and imputing a sample size. So I'm going to say that there's 20 people per group, and that's fairly large, so that means if I had 3 groups, which I'm going to go ahead and leave as, that means I've got 60 people total in my sample. I also get to, in this data simulator, identify the standard deviation per group. So remember, standard deviation squared is variance, so that's going to be something that's looking at the bottom of my ANOVA. And then I get to go ahead and enter in the group's mean. So I went ahead and just put 10 for group 1, 12 for group 2, and 14 for group 3. And then I am going to go ahead and click. I want to do the Tukey post hoc as well. And I'm going to click generate. And so the awesome thing that's going to happen now is it's going to show us some output. I can get it to appear. So I've got it showing now, and so you can see the bar graph. And again, a bar graph is inappropriate for a one-way ANOVA. So I've got 3 different groups here. These are showing my 3 different means, and these are my error bars for standard error. And then it's showing me my output table. And so you can see the degrees of freedom between is 2. You can see the degrees of freedom for the residual is 57, which is not quite how we calculated ANOVA when I've taught you, but that's fine. And then you're going to go ahead and see the sum of squares, and then the sum of squares for your denominator, so residual is error. Then you're going to see your mean square for your between and your mean square within, and then 83 divided by 10.83 is 7, and this is a highly significant ANOVA. So then it goes through, it gives us our eta squared, and so the eta squared is 0.2149. And so that's 21% of the variance in the dependent variable is explained by the independent variable. And then it goes through and it shares the post hoc. So with the post hoc, we see that groups 3 and 1 are significant. And so again, that p-value is for the Tukey. And then groups 3 and 2 are significant. That p-value is 0.03. And then groups 1 and 2 are not significant. P is greater than 0.05. All right, I now want to do the same simulation with you, but I'm going to give us a large standard deviation. So we're going to have a standard deviation of 13 per group. All right, and then I'm going to go ahead and keep my means the same, and I'm still going to do the post hoc, and I'm going to set generate. And so now you can see a very different report. Again, I still have the same means for each one of my 3 groups. The only thing that I've changed is standard deviation, which goes to the denominator. And so you can see there is a big contrast now amongst these 3, but there's a lot more variation, large error bars happening. I also can look through and see that I still have a significant F here. All right, so I'm going to go ahead and make our variance even bigger. And I'm going to change, well, I'll still keep my between groups the same. Actually, I'm also going to have our sample size shrink because sample size is connected to power. And we're going to go ahead and press generate one more time. Okay, and so here we see a large variance. Again, that 20 is huge. There's too much in-group individual differences going on within each group. You can see that F is 1.86 with a p-value of greater than 0.05. So I don't have a lot going on here. Interestingly, I still would share effect size. My eta squared is still large. my eta squared is still, it's in the small range, a 0.12, 12%. And so I said large in that it's still small. So this could be an indicator that I've got a small sample size, which is lessening my power. So power could be an issue here. Definitely, I've got large variation within each group, and that is very bad. Okay, so now I want to talk to you a little bit about your homework. Your homework, I want you to go through and listen to this NPR piece. I gave you a little bit of a summary going on there. So then you're also going to answer some questions from the NPR study. What were the basic findings? Tell me the IB, tell me the DB, tell me the study design. If you wanted to print this or take notes, you could. A lot of these questions are going to be repeated on your homework, which can be answered in a text box or you can type it up. I didn't ask you in the homework what ANOVA stands for, but that's analysis of variance. But I did ask you why ANOVA was used in the sum for the study. And then, so I made up some data that is kind of analogous to the study that was done. And so this shows you the output. And so in this procedure, I had 3 different groups. I had a music group, a book group, and a silence group. And I had a max of a 10-point scale. This shows you the initial ANOVA output, but I'm going to go over it in a minute. Because we're running a between groups ANOVA, you have to check Levine's, which is that idea of homogeneity of variance or equality of variance. So homogeneity is another name. We talked about equality of variance for between subjects design with t-tests. You can see this P, oops, I didn't mean to do that. Your P right there that I just covered over, but you can see in your handout, is greater than 0.05, and you need it to be greater than. That means you've met that assumption of homogeneity of variance. I went ahead and gave you some descriptives. Your descriptives there go through and show you the 3 different groups. So each group had 20 participants, so I had a total of a big N of 60. And my K is 3 different groups. The mean for pain for group 1 was 5. Then we had the mean of 4.8 and the mean of 7 in group 3. I had my standard deviations of 1.78, 1.2, 1.95. And then again, standard error, which kind of looks at standard deviation in along with sample size, to give you an idea of that idea of spread. So again, we see these differences amongst these groups. Are they different enough? So again, a nice bar graph to kind of show you with the confidence intervals. So confidence intervals are different than error bars. Confidence intervals give you, this is within a 95% of your sample. The bottom 5% hits here, the top 5%, that 95% hits there. And then these dots are your mean. So I went ahead and filled in as if it was bar graphs. So you had your music condition, your book condition, and your silence condition. And again, my IV's nominal, my DV's so then we'll go ahead and look at the F. Your F is 10.6. That's huge. And your P is less than 0.01. That's awesome. Again, for our ANOVA table, 59.2 divided by 2 is 29.6. 159.2 divided by 57 is 2.79. Again, residual is the same term as error. This is your within. So I apologize, in my initial videos I didn't talk about it in terms of this term residual. So our ANOVA table, again, we got the Levine's test to know it's good. We can interpret this data. I have a significant F that's an omnibus F. So I know there's group differences. I don't know which groups are different. So I need to do the post hoc. The other thing I want to do is effect size. My effect size is 0.27. That's my eta squared. So the percentage of variance, I'm seeing 27% of the variance explained from pain being explained by these differences between these 3 different conditions. Okay. So what's going on with these three conditions? I then did a post hoc, and actually I talked about the Tukey versus the Scheffé versus the Bonferroni very briefly in the lecture, and so I'm showing you I ran them all, and you're seeing it's a fairly similar story, and so I'm highlighting that you're seeing differences in your music group compared to the silence and your book group compared to the silence. So it seems like when an individual is listening to something, that lessens their pain. And so again, these are just the post hocs that help you decipher which groups are different. So again, this output connects to, and you'll see this as a handout, it connects to your homework. The other part of your homework is an Anova table. And so your Anova table, I have a video of that, but it really is this table right here. So this guy right here, you're going to be doing those formulas. So this divided by that equals that, and this divided by that equals that. And then you're going to do your mean squares divided by each other, and that's going to equal your F. And then for your sum of squares total, it'd be you'd add these to get your total, you'd add these to get your total, and you don't have a total for mean squares. And so you're going to be filling in one of these tables with some of those missing things you're going to fill in for the homework. Again, if you have any questions about any of the homework or anything going on with Anova, feel free to reach out to me. I hope you're having a great week, and thanks for your attention.